Hello everyone, welcome to SciMath. Today we have FD equal to MA Tongues Test 2011. This is the first entrance test for United States Physics team. And we have 25 questions and 75 minutes, so let's start. So let's look at the first question. A cyclist travels a constant speed of 22 km per hour except for 20 minutes stop. A cyclist's average speed was 17.5 kilometers per hour. How far did the cyclist travel? So first we have the speed times the time. Let's define it as x time, which is the distance it traveled, divided by the total time. Total time, which is because it stopped for 20 minutes. 20 minutes is 1/3 hour, so x plus 1/3 is the total time, and x is the time it was running. And average speed will be equal to 17.5 kilometers per hour. Then we solve the equation for x. We get 17.5 over 3 over 4.5. We solve the equation x. Then the answer we get is, let me plug in the calculator. The answer is 1.29. 1.296, okay? So that's the time it travels. So the time it travels, distance is equal to time times speed. So the answer is A, 28.5 kilometers. So let's look at the second question. Rank the magnitude of the average acceleration during the 10-second interval. So first, let's define what is average acceleration. Well, the definition for average acceleration is equal to the initial, the final velocity minus the initial velocity over the time. So we only want to find the magnitude. So the first, second, and third picture, we can see the change in velocity is always 2, and the time interval is always 10 seconds. So we can see easily that all the average acceleration is the same, so it's E. Then the third question, rank the magnitudes of the maximum velocity achieved during the second interval, the 10-second interval. So let's see. So let's compare the maximum velocity for each. It's 4, 2, and 2. So object 1 travels fastest, and object 2 and 3 travel the same. So answer is D. On the fourth question, rank the magnitude for the distance traveled during the 10-second interval. So now we need to calculate the area under all the curves, because we only want to consider distance, not displacement. So we just calculate all the area under instead of minusing that's 2. So we have 8 times 4 over 2 minus 2 times 2 over 2. Oops, that should be a plus. Sorry. The second one is 9 times 2 plus 1 times 2 over 2. And the third will be 6 times 2 over 2 plus 4 times 2. Then we solve each of them. We get 6 plus 8 equal to 14. Second one is equal to 18 plus 1, which is 19. And the third one, we have 16 minus 2 equal to 14. Well, actually, we should have a plus sign there. We made a mistake. So let me fix that. Let's put plus sign here and here. So we got the final answer should be 18. 18. So 19 bigger than 18, bigger than 14. So object 2 is faster, have more distance than object 1, than object 3. So it should be B. 2. So question number 5. A crude approximation is that the Earth travels in a circular orbit about the Sun at a constant speed. At a distance of 150 million kilometers from the Sun, which of the following is the closest acceleration of the Earth in orbit? So first we need to find out the period of the Earth, which is 355 days times 24 hours times each hour have 3,600 seconds. Then we calculate that. We get 31536,000 seconds, which is how many seconds in a year? Actually, not that much. Then that would be the period. Then we have the circumference divided by the period, which is the velocity. And velocity squared over r is equal to acceleration. Then we just calculate everything and plug them in. We will get the desired acceleration. So let's use our calculator, plug them in. Let's try. So the final answer we get is 0.00595 meters per second square. So it's B. Okay, the acceleration is not that much. Then the second one, question number six. A child is sliding out of control in velocity vc across a frozen lake. He's head on into another child initially at rest with 3 times the mass of the first child, who holds so that the two now slide together. So it's a inelastic, perfectly inelastic collision. What is the velocity of the couple after the collision? So instead, use the conservation of momentum, mv equal to m plus 3m, v prime is the final velocity. Then we get 1/4 of the gravitational v, which is E. This one is easy. Then question number 7. An ice skater rotating about a vertical axis with an angular velocity omega naught. By holding her arms straight out, she can then pull her arms closer to her body so the angular velocity changes to 2 omega naught without the application of any external torque, so angular momentum is conserved. What is the ratio of her initial rotational energy to her final rotational energy to her initial rotational energy? So because the angular momentum is conserved, we got I1 omega naught equal to I2 2 omega naught. Then I1 equal to 2 I2. Then initial rotational energy is equal to 1/2 I1 omega naught squared, which is the kinetic energy, rotational kinetic energy of the initial state. Then we have 1/2 times I2 times 2 omega naught, all of them squared, equal to the second rotational kinetic energy. And we divide the final to the initial. We have I1 times omega naught squared divided by 2 I2 times omega naught squared. Then we cancel them out, we get 1/2. Oh, why? There's no 1/2. Oh, okay. We've accidentally switched the first and final kinetic energy, so we just switch them back. So answer is 2. So it should be B. When a block of wood with weight 30 newtons is completely submerged underwater, the buoyant force of the block of the wood from the water is 50 newtons. When the block is released, it floats at the surface. What fraction of the block will be visible above the surface of the water when the block is floating? Okay, so here we need to use the definition for significant gravity. So we know the volume submerged in the water times the density of water is equal to the density of the original object times the total volume. Then we transfer to the ratio of the density with the ratio of the volume, we get this expression. Then we know that the buoyant force is equal to 50 newton. So rho of water times Vg equal to 50 newtons. And we know the weight of the wood without submerging water is 30. So the rho of the object times V times G equal to 30 newtons. Then we can find the ratio between water and the object density is equal to 5/3. So we need to know the original volume divided by volume submerged into the water is 5/3. Then we flip that, which is 3/5. Then we want to find the floating volume, not the submerged volume. So we need to have 1 subtract 3/5, which is 2/5, which is D. Then question number 9. A spring has an equilibrium length of 2 meters and a spring constant of 10 newtons per meter. Ad is pulling on one end of the force with a force 3 newtons. Bob is pulling on opposite side of the spring with force 3 newtons. In opposite direction, what is the resulting length of the spring? So here, this is a very tricky question, which is commonly seen in many physics exams. The physics teacher like to trick people with that, because it seems like the total force pulling on the string is 6 newtons, but actually it's only 3, because one of the force component is just making the string stable. Imagine it only have one force pulling on it, it will just flow in a free space. It will have acceleration. 1 newtons just to stabilize it, another force is stretching it. So that would be a pretty good way to think about it. I like to think about it in that way. So we just use 3 newtons divided by the spring constant, which is 0.3 meters, plus 2 meters original length, which is 2.3 meters, which is C. So question number 10. Which of the following changes will result in an increase in the period of a simple pendulum? So let's see. Letter A, decrease the length of the pendulum, definitely not. B, increase the mass of the pendulum, doesn't contribute at all. C, increase the amplitude of the swing, probably not. Probably Probably yes, because when the theta, the angle theta is bigger, probably increase. So number D, when you put a pendulum in the elevator accelerating upward, will make the gravitational acceleration seems bigger, which will cause the pendulum to swing faster, so the period is smaller. So D is also not right. Number E, because in constant speed, so not acceleration at all, so not gonna do any work. So question number 10 is equal to C. As we can see, when amplitude get bigger, amplitude get bigger, it will get a longer period. Question number 11. A large metal cylindrical cup floats in a rectangular tub, half filled with water. The tap is placed over the cup and turned on, releasing water at a constant rate. Eventually, the cup sinks to the bottom and completely submerged. Which of the following of the graphs could represent the water level in the sink as a function of time? So here I'm just sketching a rough sketch. Oops. I want to draw a square. Okay. I want to draw a cup in a sink. Yeah, have water level in each of them. The cup is iron, and there's a tap placed over the cup, turn on, and putting water into this cup, making the water go over and over until the cup sinks into the water. Okay, so I'm gonna draw a tap. This is a tap. Yes. Okay, and water is going into this cup. Boop, 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 boop. Yeah. Okay. So first, let's think about it. When you pour water into the cup will sink and sink and sink. So the water level will rise up and up and up. Then suddenly, when the cup suddenly drop into the water will flood into the cup and make the surface suddenly drop a little bit than the original volume inside the cup. So have a sudden drop. Then pretty much we can erase answer A, B, and D. So C and E, what's the difference between C and E is the rate of the increase of the surface after the drop. So are they the same slope or different slope? Well, when we pour water into the cup, the density, well, we know the Archimedes principle. The density of the water times the volume replaced by this thing, by the water, should be equal to the buoyant force. So the beginning of water has the same density and same volume of submerged. And the second one, the water just flow into the tank, so the slope should be the same. So it should be should be C. So question number 12. You are given a large collection of identical heavy balls and lightweight rods. When the two balls are placed at the end of the rods instead through the mutual gravitational attraction, its compressive force, the rod is F. Next, 3 balls and 3 rods are placed at the vertical edges of the equilateral triangle. What is the compressive force in each of the rods in this case? So let's assume that all the forces are F first. Then we can know that each of the force have action and reaction pair. So we can see it's C. Well, you might ask that what if F? I think F should be bigger than original F, because 2 of the other forces are also compressing the each of the other 2 of the other rods are also compressing the third rod. But you also want to know if some of the components get into compressing to the other rod, Newton's third law will never hold, because 2 magnitude of force won't be equal and opposite. So the answer is C. 13. Question number 13. The apparatus in the diagram consists of a solid cylinder of radius 1 cm attached to the center of the 2 discs of radius 2 cm. It is placed on a surface where it can roll but will not slip. A thread is wound around the center of the cylinder. When the thread is pulled at an angle of theta equal to 90 degrees to the horizontal, directed up, apparatus roll to the right, which below the largest value of theta, for which it will not roll to the right when the pull in the thread. So here is a static equilibrium problem. We have to consider torque and the force. We know the vertical force cancelled out, so let's assume the normal force of this cylinder to the ground is equal to N. So we have F times cosine theta equal to N mu. Equal and opposite have to be stable. Then we consider the torque of the entire system. mu times 2 cm. As cm, we can see the both sides cancel out. We just said 2, if equal to F times sine theta times 1. So we know that n times mu, oops, not this, n times mu is equal to F times sine theta over 2. Now we can equate them because n over mu is also equal to F times cosine theta. So we have sine theta over 2 equal to cosine theta. So we have sine over cosine theta is equal to 2. Then we can solve tangent theta equal to 2. Then what is tangent theta equal to 2? Let's use our calculator to calculate that. So the answer we got is theta is approximately equal to 63.4. Well, it's closer to D, so the answer is D. Then we look at the 14th question. You have 5 different strings with weights tied to the various points, all hanging from the ceiling and reaching down to the floor. The string is released at the top, are allowing the weights to fall. Which one of the creating regular uniform beats sound as the weight hits the floor? So first we want to know that when the ball drops, the acceleration there's acceleration, so the speed is faster and faster. So B and A definitely doesn't work because we want the distance to be far away when in the top and not uniform, because the acceleration and the speed gets faster and faster. So A and B is not right. Then in C, D, and E, what we need to consider is the rate of the beads ratio between the distance between each of the ball in order to make the beads uniform. So first, let's assume that T is the bead period, each bead, the difference between each bead. So 1/2 gt squared equal to h, and 1/2 g2t squared is equal to how many times h? Then we know 1/2 g2t squared is equal to 2 gt squared, which is 4 times h. So the first bead and the second bead have first ball and the second ball have the same bead, have a 4 times difference. So let's count. In question number D, first ball and the second ball have one distance. The first ball and the third ball have 4 difference. The first ball with the fourth ball have 9 difference. Okay, what about E? The first ball and second ball have 1 difference. The first ball with the third ball has 5 difference. And this number C, first ball and second ball has 3 difference, which is not true. The first ball and the second ball should have 1 difference, and first ball and the fourth ball should have 4 difference. So D should be correct. Then question number 15. A vertical mass spring oscillator is placed 2 centimeters from equilibrium. The 100-gram mass passes through the equilibrium point with a speed of 0.75 meters per second. What is the spring constant of the spring? This is just a simple energy conservation. 1/2 mv squared equal to 1/2 ka squared. Because we already have the equilibrium position displaced by the gravity, so we don't need to consider gravity. So we just cancel out 1/2, and then we have 0.1 times v squared, which is 0.75 squared, equal to k times a squared. And we divide both sides by a squared, which is 0.02 squared, which is equal to k. Then we calculate k. What is k equal to? Let's plug into our calculator. K will be equal to D. Okay, 140. Okay. So question number 16. What is the magnitude of the force does Joanna need to exert on the physics textbook to keep the road from slipping? So first, this is a pretty long question. You just read it yourself. Basically, this Jonathan is pushing the book to a fixed hard rating with a force F to make friction to stick the rope, so the rope will handle the mass of the Becky. So we know Becky, let's see, they have a mass of m. Also, mg have equal to F times the static friction force. So F equal to mg over mu s. So it should equal to E. This is simple. Then question number 17. Jonathan applies normal force that is just enough to keep the rope from sailing, but Becky makes a small jump, he's naughty, leaving the contact with the force of blocks. Upon landing the box, the impact caused the rope to start slipping from the other hand, but with a constant speed. Oh no, not a constant speed, but a constant acceleration. What is the speed of the box smashing into the ground? So we know now we calculate the acceleration of the box by the net force divided by m equal to a. Then we will use 1/2 at squared equal to h to calculate the t, how many time it need to slide to the ground. So we have t equal to 2h over a and all of them square root. Then we know 2h times m over a is equal to mg minus f mu k divided by m, because this time it's kinetic friction, not just static friction. And kinetic friction is smaller than the static friction. Then we plug in f to the equation. We have 2hm over mg minus mg times mu k divided by mu s. So now this should be the time it takes for it to fall. Then the time it takes to fall times the acceleration will be the speed it hits the ground. So now let's calculate the speed. Yeah, let's calculate the speed. Oh, but before that, let's simplify a little bit more. So we have 2h over g times 1 divided by 1 minus mu k over mu s. Okay, so that's the time it takes. Then let's calculate the speed. So we have ta is equal to v, final velocity. So ta is equal to, let's plug them in, a and t. We have 2h divided by g times 1 over 1 minus mu k divided by mu s over the square root times a, which is mg minus f mu k divided by m. F mu k divided by m. That's a pretty long expression. So we write them down, and then we also want to plug in f by the way, cancel m. Then we can simplify this expression a little bit more. So we move them down to here. It's a bit space a little bit, not allowed. It's fine. So we get the simplified equation equal to 2h over times g, because we also plug in g from right side. Then times 1 minus 1 over mu s divided by 1 over mu k over mu s square root. Also 1 over mu s is a square. Don't forget about that. So after to simplify all this, it's a little bit hard, but trust me, I simplified this. Before I got the answer should be the square root of 2gh times the square root of 1 minus mu k over mu s. Okay, all of them square root. So that will be the answer. So the answer is D. Okay, let's look at question number 18. A block of mass 3 kg slides down the ramp and then up a second ramp. The coefficient of kinetic friction between the block and each ramp is equal to 0.4. Then the block begins a height of h1 equal to 1 meters above the horizontal. Both of the ramps are at 30-degree incline above the horizontal. To what height above the horizontal does the block rise on the second ramp? So first, let's draw a diagram here, a picture here. We have two ramps. We have draw two triangles. Each is a vertical right triangle and have an angle of 30 degree. 30 degree. Okay. Then we know the ball. Wait, it's not perfect enough. Okay. Each of the ramp has 30-degree angle on the bottom. Then we want the ball to slide from the top of the first ramp, and we know the height of the ball slide down is equal to 1. So according to trigonometry, the length of the ramp will be 1 over cosine sine of 30 degree, which is 1 divided by 1 over 2, which is 2. Ball slides down, then we can use the conservation of energy. The first gravitational potential energy is equal to the second gravitational potential energy plus the work done by the friction, which is mg cosine theta times mu times 2, which is the first ramp. It has to go through the first ramp, plus the distance it goes through the second ramp, which is h2. h2 is the distance above the height above the horizontal, divided by sine of theta, which is sine of 30 degree, which is 2h2. Then we solve this expression. we cancel all the mg's. We solve h2 with the expression. We know h1 is equal to 1. So 1 equal to h2 plus cosine theta is just the square root of 3 over 2 times 0.4, which is mu, times 2 plus 2h2. Then we plug them in, expand them, which is 1 equal to h2 plus square root of 3 over 2 times 0.4 plus 0.4 times square root of 3 times h2. Then we factor out h2 together. We have 1 minus 0.4 square root of 3 over 1 plus 0.3 times square root of 3 equal to h. Then what is h? H will be equal to, let's plug in calculator. H should be equal to 0.1814, which is 0.18 meters. Let's look at question number 19. A particle mass 2 kg moves under a force given by this equation, where I hat and j had a unit vector in x and y direction. The particle placed in the origin at initial velocity 3i plus 4j. After how much time will the particle first return to the origin? So first, we can see that this force is clearly a spring force, negative kx, exactly the spring equation. So in the spring equation, we want to know the time, we want to find the period of the spring, which is always period of spring always equal to 2 pi times the square root of m over k. We know k is equal to 8, as you will see, and mass is equal to 2. So we have 2 pi times the square root of 4 is equal to 4 pi. Oh no, sorry. 2 over 8 is equal to 1 over 4. So equal to 2 pi times square root of 1 over 4, which is equal to pi. But here we want to find the time it returned to the origin, which is a half of the period. So half of the period is pi over 2, which is approximately 3.14 divided by 2, which is approximately equal to 1.57, which is C. So, question number 20. What is the maximum distance between the particle and the origin? Here we want to use conservation of energy to find maximum displacement in the x and y direction. So maximum displacement in the x direction is equal to ax, and the maximum displacement in the y direction is ay. This is just conservation of energy. Then we solve for ax and ay. Then we use Pythagorean theorem to find them out. So first one we solve is equal to 1/2 times m is equal to 1. The velocity in the x direction is 3 squared equal to 9. 9 equal to 1/2 of times 8 is 4 times a squared. So a is equal to 3 over 2. This is ax. Then ay, square root of ai y times 4 is equal to 4 squared equal to 16. So ay is equal to 2. So now we use Pythagorean theorem. 3 divided by 2 square plus 2 square root is equal to the maximum distance between the particle and origin, which is 4 divided by 9 divided by 4 plus 4, which is equal to 45 over 4, and then all square root. So let's calculate that. Oh no, sorry, mix up. 9 over 4 plus 4 is not equal to 45 divided by 4 is equal to 25 over 4. Okay, sorry. So let's fix that. It's not 45. It's equal to 25. So the answer will be 5 over 2 square root, which is 5 over 2, which is 2.5. So the answer will be B. Then question number 21. An engineer is given a fixed volume Vm of a metal with which to construct a spherical pressure vessel. Interesting, assuming the vessel has thin walls and always pressurized to near the bushing point. The amount of gas the vessel can contain N does not depend on the radius of the vessel, but depends only on the volume and the temperature and the ideal gas constant and the tensile strength, which of the following give N in terms of these parameters. So this is simply a dimensional analysis problem. So we put on all the dimensions, set them to a power. We have N moles equal to volume A to the A power times K to the B power times joule divided by kn to the c power times n over m squared to the d power. That's u to d power. We know joule is equal to force times distance. We can replace them to an even more fundamental unit, so n times m. So now we have 3a plus c is equal to 2d, right? Because first we consider m, or d is here. Because we know that the final equation doesn't have anything about mass, so mass have to cancel out, right? And b, let's consider temperature. B have to be equal to c because k and k have to cancel out, and c equal to negative d. Why? Because c have to be equal to negative d, and c equal to minus 1. C have to be negative d because newtons have to cancel out. C equal to negative 1 because it's the only term that have most in it, which we in the final equation. Then we solve for b, solve for d, then we plug b into a, we solve for a, and we got c equal to negative 1, b equal to negative 1, oh sorry, that's negative 1, not 1, d equal to 1, and a equal to 1. So let's plug them all in, transfer this expression into our equation. We know n is directly proportional to Vm, which is a, times b, which is negative 1, so divided by t, and c is also equal to r, so divided by r, times tensor strength, which is directly proportional to this thing, which is a. Okay, there's nothing else as cube root something, right? So question number 22. This graph depicts the torque output of a hypothetical gasoline engine as a function of the rotational frequency. The engine is incapable of running outside the graph range. So here, what is the engine RPM? Does the engine produce maximum power? So we know power equal to torque times omega, and the bigger the frequency, the bigger the omega, right? So we only see the area under the graph at the point, the frequency rotational revolution per minute times the torque have to be biggest. So the largest point, highest point on the graph, we have 45 thousandths of, and then on the left hand side we can pretty obviously they are smaller, area smaller. Then on the right hand side, let's just check one point on the right hand side which is probably bigger. Let's check. So it's about 1750 times 27.5, which is bigger than the highest point. So we find a point on the right side of the graph bigger than the already tallest graph in the graph. So the answer should be D, some point between 2 and 3. Right. So last, we see a particle is launched from the surface of a uniform stationary spherical planet at an angle to the vertical. The particle travels in the absence of air resistance and naturally falls back to the planet. Placement Fred describes the path of the particle as a parabola using laws of projectile motion. Spacewoman Kate recalls from Kepler's law that every bound orbit around a point mass is an ellipse, and was gravitational due to the uniform sphere of identical to the point mass. Which of the following best explains this discrepancy? First, let's see, because experiment placed very close to the surface of the planet, it's no longer valid to replace the sphere of the point mass. No longer valid? I don't think so. It's just so valid because the spherical symmetry, we can also consider the planet as a point mass. Remember, on Earth, we calculate the distance between the center of the Earth to you to calculate the gravitational acceleration. B, because the particle strikes the ground, it is not in orbit of the planet. Do you have to be in orbit of the planet to apply Kepler's law? No, I don't think so. C, K describes the fact the motion around the planet also be parabola or hyperbolas. Well, that's true, but that's only happen when the velocity of the like common around on the sun is very, very high. But here it's not the case. It's just very low and it's on the ground of the planet. So it's not right too. So D, Kepler's law only holds the limit of large orbit. That's also not true. That's definitely not true. So E, the path is an ellipse, but very close to a parabola due to the short length of the flight relative to the distance from the center of the planet. That one's right. So the correct answer is E. So 24. Now question number 4. A turntable is supported on a Teflon ring of an inner radius r and outer radius r plus epsilon. Epsilon is very, very smaller than r, as shown in the diagram. To rotate the turntable at a constant rate, power must be supplied to overcome friction. The manufacturer of the turntable wishes to reduce the power required without changing the rotation rate, the weight of the turntable, or the coefficient of friction on the telephone reverse surface. Engineer proposed two solutions: increase the width of the bearing or increase the radius. What is the effect of the purpose changes? First, we know that delta is much smaller than r, and we know that by increasing the and we know that the moment inertia of this ring is proportional to r squared. By increasing the moment inertia, we can increase, and because rotational rate is still the same, so we increase the kinetic energy, which increase the power. So we know delta is much smaller than r, so increasing r doesn't give us a significant effect. And increasing r, you could increasing moment inertia, which increasing potential energy. So we have A, increasing, which is equal A. Yeah. Question number 25. A hollow cylinder with a very thin wall, like a toilet paper tube, and a block are placed at the rest of the top of a plane with inclination of theta above the horizontal. The cylinder rolls down the plane without slipping, and the block slides down the plane. It finds that both objects reach the bottom of the same plane, simultaneously. What is the coefficient of kinetic friction between the block and the plane? So here we have two ramps, identical ramp, with one roll down a hollow cylinder, another one roll down is a block with some friction. Oh, this block is not very well drawn. Let's rotate a little bit. Okay, here we go. Oh, okay, let's rotate again. Here we go. Okay, here we go. Now we can know the kinetic, the acceleration for the center of mass of the cylinder is equal to, we can calculate this by the torque it exerts on it. So we have the moment inertia times the angular acceleration. Where is that? To draw again, angular momentum, moment inertia times the angular acceleration is equal to the torque, which is mg cosine theta times mu times r, which is equal to torque. So what is the moment inertia is equal to 1/2 of a hollow cylinder is 1/2 times mr squared times times alpha equal to mg times cosine theta times mu times, oh, we lost r. R cancel out, so we also cancel out. So we have a which is equal to r times alpha, which is 2g times cosine theta times mu. Right. Then we calculate a acceleration for the ramp, for the block on the ramp with the existence of friction. So we have mg times sine theta minus mg times cosine theta mu, or divided by m, f divided by m equal to a. So a equal to g times sine theta minus mu cosine theta. And we equate to a be the same. Then we have g times sine theta minus cosine theta is equal to 2g times cosine theta mu. Then g cancelled out. We have sine theta is equal to 3 cosine theta mu. Wait a second. That's not right. Oh, we forgot. It's a hollow cylinder, not a uniform cylinder. So the coefficient equal to 1, just 1, mr squared. So we need to cancel that 2, which finally we have mu is equal to 1/2 tangent theta. 1/2 tangent theta. Oops. Okay. So the answer should be C. So thank you for watching. I hope you enjoyed this video. And thank you for the American Physics Teacher Association produced the solution manual, which we referenced.